All right, we're ready for page 3 of the 7-1 notes, and we're going to start to talk about slope. So we're going to define slope in a few different ways. So a lot of you may have heard that slope is rise over run, right? So I'm going to write that down. So rise over run. And you may look at me like I'm crazy because I spelled rise incorrectly. And you're correct, I spelled it incorrectly, but I did it for a reason. The most common mistake when people are finding slope is they will subtract the x's on the top. But if I spell rise incorrectly, it gives me a little mental note that the y's are actually on the top. Rise over run, we look at the change in y over the change in x. Maybe you've seen this Greek letter delta, which is a little triangle, right? For change represents change, so you might have heard this as change in y over change in x. Yeah, so how do we find the change in y? Well, we subtract the y's, right? So if you have 2 points, x1, y1, x2, y2, the change in y we can find by taking y2 minus y1, and the change in x we can find by taking x2 minus x1. And we want to make sure that we subtract in the same direction. So if we do y2 minus y1, we want to do x2 minus x1. You could also subtract the other direction, but you want to make sure you stay consistent with both the x's and the y's. So we could actually do y1 minus y2 on the top, but if we do, we have to do x1 minus x2 on the bottom. So either one of these would be okay. I usually like to stick with this. So just identify which point is your x1, y1, which one is your x2, y2. So let's just jump into some examples. So we have example 8 here. 4, 3, I'm going to make that my x1, y1. 3, 5, I'm going to make that my x2, y2. And then I can subtract the y's, subtract the x's. I'm going to use this guy right here. So 5 minus 3. And slope, by the way, is usually given in algebra the variable m. And so it has to do with some Latin word. You can look that up if you're curious, why we use m for slope. You could Google that if you're curious about the history of that. But we use the letter m, lowercase m, to represent slope. So now y2 minus y1, so m is equal to 5 minus 3 on the top, over x2 minus x1, so 3 minus 4 on the bottom, right? So we get 5 minus 3 is 2, 3 minus 4 is negative 1, so we could simplify, that's just negative 2, right? So that means for every 1 unit change in x, we decrease y by 2 units. Or if we look at the fraction, this means for every 2 units increase in y, we decrease 1 unit in x. So we can think of it that way as well. But our slope is negative 2 here. The next one, let's see, 7. We'll do the y. I'm not going to label these this time. I'm going to consider the second point my x1 or x2, y2. So we'll do 7 minus negative 2. That's my y2 minus y1. And 2 minus 5 on the bottom. That's my x2 minus x1. And then I'll simplify. Minus a negative is plus, so that's 9. 2 minus 5, that's negative 3. We can divide, and what do we get? Well, we get negative 3, right? Now, if your answer ended up being a fraction that could not be reduced, you could just leave it as the fraction. In fact, fractions are probably a little bit better than decimals in this case, because you can see units change in y, units change in x. If you have just something like this, it's really negative 3 over 1, so for every 3 unit decrease in y, we increase 1 unit in x. There's an understood 1, it's over 1 really there. Alright, let's look at a couple others that are a little bit strange. So if we do negative 3 minus 2 here, do that, negative 3 minus 2, that's y2 minus y1, over 7 minus 7. 7 minus 7. That's 0, right? So what we end up with, negative 3 minus 2 is negative 5 divided by 0. But we can't divide by 0. So what that means is the slope is undefined. Undefined. So if you end up with an expression where you're dividing by 0, you can say your slope is undefined. And if you were to plot these points, you would find that you get a vertical line. Okay. So if we're on the coordinate plane here somewhere, and we have 7 over here, right? And 2 is up here a little ways, right? And negative 3 is down here a little ways. So if we were to connect those points, we get a vertical line, right? Vertical lines have undefined slope. Okay? If you think about it, you cannot really walk up this line, right? And that's one way I like to think of it. Slope's undefined if you cannot walk up it. So it's impossible to walk up a vertical building unless you're Spider-Man or something like that. All right, so anyway, this is an undefined slope. Now let's look at another special case here. Here we have negative, so m, y2 minus y1, negative 5 minus a negative 5. x2 minus x1, negative 1 minus 3. So on the top there, what do we get? Negative 5, this is really plus 5, which we get 0. On the bottom, we get negative 1 minus 3, which is negative 4, right? So 0 divided by negative 4, we can do that. 0 divided by any non-zero number is just 0. So we get a slope of 0. And this happens if we have a horizontal line. If we were to plot these two, let's see, where would we be? So down here somewhere we're at negative 5, right? And so we have 3, 1, 2, 3 negative 5, and negative 1, negative 5 would be around here. So we would get a horizontal line, right? So any line that has slope 0 would have would be a horizontal line. All right, so let's look at a couple other examples here. So anyway, m is equal to 0 for that one. Slopes is 0. All right, so let's see. Graph the line. We're given a point and a slope. And so there's a nice way to graph a line if we're given this information. So let's go ahead and plot the point. We need 1 point. 4, negative 2 is right here. Here we're told the slope is negative 1. So remember, now I'm going to go back to the rise over run thing. So I'm going to write this as a fraction, negative 1 over 1. Okay. What that tells me is I'm going to rise negative 1 and run 1. So a rise of negative 1 means I go down 1, right? So I go down 1. And a run of positive 1 means I go to the right 1. So I could go down 1 and to the right 1 and get another point. I could go down 1 to the right 1 and get another point. So I could do that forever. Now if I run out of space on my grid, guess what I can do? Well, negative 1 over 1 is the same as 1 over negative 1, isn't it? And so if we think of this as our rise over run, positive 1 means I could start at my original point, 4, negative 2. I could rise 1. And then a run of negative 1 means I go to the left 1. So I could get a point that way too. Now you only really need 2 points. In my lab you probably only use 2 points, but you could get as many as you wanted also. I could continue to go up 1 and left 1, up 1 and left 1, up 1 and left 1. I could get as many points as I wanted to, really. But if I want to graph the line, then I just connect them. And there's my line. So let's look at the next one. We have negative 3, negative 2, and m, our slope, is 2/3. Okay. So I'm going to plot that point, negative 3, negative 2. And my slope is 2/3, so that means I'm going to rise 2 and run 3, right? So that means up 2 to the right 1, so up 2, and then to the right 1, 2, 3. Oh, look, I get a point right there. You only need 2 points, and that would be enough. Now I could also, if I wanted to go the other way, 2/3 is the same as negative 2 over negative 3. The negatives essentially cancel out. But I could go down 2 and to the left. 1, 2, 3. Get another point. Should still follow the same line. Now you only need 2, but if you want more, you can get more. I connect these and get my nice, beautiful line. Alrighty, so that's it for this page. I'm going to stop the video here. We'll continue in the next one.